The third sheet in your mechanical commissioning checklist is this wiring and enclosures. So I'm going to click on that and bring up the choices. Let's walk through what you check for wiring and enclosures. First thing, I'm going to teleport to the first location, which is talking about checking my wiring and my conductor terminals, checking to see if they're tight. I'm going to teleport to that location. Takes me to the AC disconnect. I want to emphasize that you always click on these eyes for more information. Always click on those before you do a step to learn about the step. In this case, it's telling you that we're going to the AC disconnect and you want to use a torque screwdriver to check the terminal torque. And the spec is 20 inch-pounds, plus minus 20%, which means 16 to 24. So that's what we're going to be checking on. Click on it to open the cover. If I click on the cover, it closes again. Click it to open it. It's pretty cool. And I click on each one of the screws here to check the tightness. Well, I check here. I bring up my torque screwdriver, and the reading says 22. Well, that's within that range of 16 to 24, so I'm good for that one. Let's check this one down here. I get 21. That, again, is within 16 to 24, so that's okay. Let's go over here. Check one here. I get 19. That's within 16 to 24, almost 20, so that's good. Check here. Oh, man. So this one is at 14. Remember, the minimum you could go to was 16. This is 14. It means it wasn't tightened enough. So you would, at this point, use the torque screwdriver to tighten that up, make it to closer to 20, and pass that test. The point here is that you would do this kind of testing with the torque screwdriver on every terminal, on every piece of equipment, to check it to the manufacturer's spec of the tightness of those connections. And don't just do it based on your own feel. So I'm going to close that lid just to cover that up. Now we're going to take a look at enclosures here. Let's go through some of the things that we're going to be checking about all the enclosures. Are they secure? So I'm going to teleport to a location. Keeps me at the array disconnect. And the idea is that, again, I read the eye to read about it. It says pull the top of the enclosure to see if it moves away from the wall. Well, so that's what we're going to want to do. So the idea is that if you roll over the object, it highlights the object to touch. And what you're going to do is grab the top and see if it's secure. Whoa, okay, whoa, it's moving. Whoa, 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 I'm clicking on it. I'm going to rotate a little bit to the side, not open it up. And I'm going to touch the top. Oh, you can see I'm touching this thing and it's moving in and out by me clicking on it. So that indicates that enclosure was not secure. What you're going to have to do is open it up and reattach these bolts here inside, somehow tightening them up and make it more secure. So in this case, for the conductor terminals tight, I should have mentioned that it was below the torque spec up there, forgot that. And enclosure secure, going to look at my choices here. Is it tight or does it pull away? And I have to report that it pulls away. That's going to have to be repaired. How about level? Let's check the levelness of enclosures. I click on my teleport. And it takes me here. Enclosure level. And I read the more info. It says select the level tool, and that's down here. That's this level tool right down here. Select the level tool and look closely at the horizontal bubbles to see if the surfaces are level or not. So going to click on the level tool, and it brings up a bunch of levels. Pretty cool, huh? And I get to zoom in this case, and it's showing me that on my objects here, my bubble is out of center here. In fact, over here as well, the bubble is out of center. That clearly means that that bubble is supposed to be right in the center to be level. So these enclosures are not level. That's not good. What I'd have to do is loosen the connections for them and retighten them so that they're all level. So in this case, I'm going to make a choice here and say they are not level. Let's look at inverter minimum separation distance. So I'm going to teleport to that. I've got my levels up, so I'm going to go down here to my level thing and click on it, make the levels go away. Now we're taking a look here to see inverter minimum separation. Let's read the information. It says, confirm that the distance between the inverter and the production meter is at least a minimum required, and this manufacturer specifies 4 inches as the minimum spacing. In fact, they say that if you're putting in multiple inverters next to each other, you have to have at least 8 inches between each inverter, but at least 4 inches over to the next enclosure. So we've already made that measurement for you, pressing and rolling here, and you can see that we indicate there's only 2 inches in between the inverter and the revenue grade meter enclosure. That's less than 4. That's no good. So over here on my choice, I'd pull down and I'd say the distance is less than 4 inches. How about the distance from a gas meter? This is a big deal, okay? I'm going to teleport here, and lo and behold, we have apparently installed the electrical equipment right on top of the gas meter. So what you do is you roll over the valve section of the gas meter to see what the minimum radius of 3 feet is, and it shows that you're not supposed to have any equipment within 3 feet of this valve of this gas meter. And unfortunately, this should have been spotted in site survey and should have been a fact that you weren't going to install any electrical equipment near a gas meter, but these guys did it. And I have actually seen this. I've seen systems that have been installed. They go to electrical or city inspection. They come out and they say, whoa, you can't put it here. You're putting your inverter too close to the meter. And they had to move all of their electrical equipment from where they'd installed it because no one's going to move that gas meter. So you had to move the solar equipment away. Big, costly mistake. So obviously something that you can remedy by doing it right from the beginning. But we check it here in mechanical commissioning as a part of our checklist. You roll over the valve to confirm or check to see if any of your electrical equipment is here. In other simulations, you may find the gas meter in some other location, and it may be okay. But in this case, I have to report that the meter is within 3 feet, and that's a fail. Then let's check the solar breaker. Check that out. So I teleport to that. I come to my main service panel. What I'm going to do is click the cover, open up the main service panel cover, and be able to look at my solar breaker that's at the top. And I check my information button here. It says, confirm that the solar breaker is securely seated. Well, I'm going to take a look here, kind of rotate around here. Whoa, look at that. Looks like that sucker is not down. It's up a ways. It's not been securely put in place. It fooled me. So that solar breaker is not secure. I would have to simply, retighten it to make sure it's positive. But I'm going to have to report here that that breaker is not fully seated. Finally, going to look at the revenue grade meter to see if that's proper. I'm going to transport to that. Looking at my revenue grade meter, it's got a couple of parts to it, right? It's got the meter itself and it's got the cover. And in this case, if I look at my information, I want to check the revenue grade meter to make sure it's properly secured and closed. Well, in this case, I got my choices here of either being secured with a cover in place or having the meter with no cover or having the cover with no meter. And I've seen it both ways. So here, in this case, we've got the meter here with the meter installed, but no cover. In the haste of doing all the work, guys have pushed on the meter but forgot to put the cover back on. So in this case, I'm going to have to select that I've got meter in place but with no cover. And then finally, let's go look at that main service panel protective shield. If I teleport over there, I'm going to look for the protective shield. Close the cover. You may have left the system like this, put everything in place, done all your wiring, let's say, close the cover and think that you're all done. But if you open up the cover, there's no cover plate. There's no protective cover over these breakers. There's supposed to be a flat piece of metal here covering this all. So I got my choices here saying the shield's in place or there's no shield. And I'm going to have to say that there was no shield. So that's the way we can go through wiring and enclosures.
Hey, thanks for watching the training video using Interplay's simulation-based training program. You can keep watching our solar videos by clicking on the link to your left, or stay up to date on our latest solar snacks by subscribing on your right. To learn more about how the STP provides critical team training and helps you build an onboarding program at your company, please go to interplaylearning.com.